You start by dragging the table you want to synthesize under the Synthesize section. Once you've done that, all the columns will be automatically fed into our generative AI model, which preserves the relationships and patterns in the dataset and regenerates them in a synthetic dataset. If you go to the column settings, you'll see that AI-powered generation is applied to all the columns. At this point, you can decide if you want to change the number of rows. You can increase this number if needed and set the number of rows the platform will generate. Once you're happy with your settings, you can proceed to generate the synthetic data. You'll be taken to the job summary page, where you can see which tables are being synthesized and which are excluded. Finally, you can start the generation process by selecting the Start Generation button. Let's start by dragging all the tables we want to de-identify into the De-identify section. As you can see, some columns are immediately marked as PII and highlighted in red, indicating their sensitivity. In the PII tab, you'll see the results from a previous scan we ran, showing the columns identified as PII. Once we confirm which columns contain PII, we can replace them with mock values. For example, if a column is marked as address, we can apply an address mocker to de-identify it. In the allergies table, there are two relationships with other tables in the database. Our platform ensures these relationships are preserved in the generated data. We also need to maintain consistency in non-key columns, for example, in the city column with values like Boston. If we want to de-identify this column while ensuring that Boston is consistently mapped to the same output value, we can do so by selecting the column and applying a city mocker. Initially, this generates random mock values, but by enabling the consistent mapping feature and previewing the values, we ensure that Boston is consistently replaced with the same new value. This is essential for maintaining consistency across tables and systems. Handling large amounts of data is another significant challenge in test data management. We might have a table with 2.15 billion records. Our platform is equipped to handle such large data sets efficiently and optimize processing speed. One way to achieve this is through parallel processing. In the advanced generation settings, you can set the number of connections to increase parallelization, allowing multiple tables to be processed simultaneously. Adjusting read and batch sizes can also enhance processing speed. Balancing these parameters with hardware capabilities enables efficient handling of large databases.